Hello everyone and welcome to Module 8, Database Optimization, Indexing, Performance Tuning and Views. In previous modules, you learned how to write correct and powerful queries, but there is a big difference between a query that is correct and the one that is fast. As your tables grow to thousands or even millions of rows, even simple queries can become painfully slow. Today, we are going to learn how to make your queries fast and efficient using indexes, execution plans, tuning techniques, and views. These are the skills that separate good SQL users from production-ready professionals. Let's begin. In this module, you will learn why optimization matters even when your queries are correct, how indexes speed up data retrieval, the different types of indexes, which are primary, unique, composite, clustered, and non-clustered. You will learn how to create, manage, and route indexes, performance tuning techniques, and common bottlenecks. You will learn how to read and understand query execution plans using explain, what SQL views are, and how to create, use, update, and drop them. We will look into practical applications of optimization in real systems and best practices for maintaining high-performance databases. You now know how to write correct queries from modules 3 to 7. But correct doesn't mean fast. When tables become large, even simple select statement can slow down dramatically, frustrating users and wasting server resources. This module teaches you how to make your queries fast and efficient using indexes, execution plan, analysis, tuning techniques, and views. Optimization turns seconds into milliseconds, and this is critical for real applications, reports, and dashboards. So, what exactly is database optimization? Optimization means making the database return the correct result as quickly and as efficient as possible while using minimal CPU, memory, and disk I/O. Common performance problems include full table scan instead of fast index lookups, missing or poorly choosing indexes, insufficient joint order, sorting or grouping without proper indexes, scanning too many rows unnecessarily. While optimizing, always measure, test using explain, then soon, never guess. Indexing in SQL. The most powerful tool for optimization is indexing. An index is a separate data structure that allows the database to find rows quickly without scanning the entire table, just like the index at the back of a book. Indexes are usually built as B-trees. They stored sorted copies of column values plus pointers to the actual rows. They dramatically speed up where clauses, joins, order by, and group by, but they become with a trade-off. Reads become faster, writes, insert, updates, and delete becomes slower because the index must also be updated. They take extra storage space. Index columns that are frequently used in filters, join, and sort, but don't over-index. Types of SQL indexes. There are several important types of indexes, which include primary index that automatically created on primary key. It uniquely identifies every row. Unique index enforces uniqueness and speed of lookups, e.g., email and learning. Composite index. It is an index on multiple columns that order of columns matters a lot. Clustered index. In clustered index, zeros are physically sorted by an index value. While a non-clustered index, a separate structure that points to the actual rows. The primary key is clustered, while secondary indexes are non-clustered. Creating and managing indexes. Let's see how to create indexes. Simple index. Create index, customer email on customer's email. Composite index. Create index on order dates, customer dates on orders, customer ID and order date. Unique index. Create unique index in invoice number on invoices. Dropping indexes. To drop index, use drop index and specify the customer email on customers. While to show index, use show index from customers to see the existing indexes. Always create indexes after loading your initial data as it is faster, and always monitor with explain to add indexes only where they are truly needed. Performance tuning techniques. Here are some powerful performance tuning techniques. Add indexes on columns used in where join and order by. Avoid putting functions on index columns. It is bad to use where year order date equals to 2025, while it is good to use where order underscore date is greater than or equals to 2025 1st of January and order underscore date less than 2026 first day of January. Use covering indexes. Rewrite subqueries as joins when possible. Always limit rows early. Use appropriate join time. Avoid using select with asterisks as list only needed columns. Update table statistics regularly. Partition large tables by range or date. Monitor slow query log. Always measure performance before and after changes. Query execution plans. Explain. The most important tool for optimization is explain. Run it like this. Select from orders where customer ID is 101 and order date greater than 2025 first day of January. Key columns to watch after you run your query. Type or rows, key, and extra. Run explain on every important query. Your goal is to avoid full table scans and file sort on large tables. SQL views. Now let's talk about views, one of the most useful features for both simplification and security. What is a view? A view is a set query that acts like a virtual table. It simplifies complex queries, hides sensitive columns, and lets you control access, creating a view. Create view active customers as select ID, first name, last name, email, join date from customers where status is active. Then how to use the view that you just created. Select from active customers the view that you just created, where join date is after 2024 first day January. Benefits of using views. You hide complexity and centralize logic, and you can restrict access by granting permissions only on the view, not the base tables. Updating and dropping views. Simple views based on one table, no aggregate or group by can be updated. Update active customer, set status to inactive where ID is 101. Drop view active customers. Use views to simplify reports and protect your base tables from direct access. Practical applications of database optimization. Let's look at some real-world examples. Slow customer search. Before, full table scan on email column, and after, create index email on customer's email, which is 100% faster. Let's look at this monthly sales report to create view. Create view monthly sales as select date format as month and sum total amount as revenue from orders group by months. To get top customers dashboard, select first name, sum total amount as lifetime value from customers. You join orders with customer ID. You group by an order by lifetime value in sending order and limit to 10. Best practices for SQL performance. Here are the most important best practices. Index aggressively on read-heavy columns, but sparingly on write-heavy ones. Use explain on every important production query. Avoid selects with asterisk. Always list the exact columns you need. Keep indexes narrow. Fewer columns, smaller and faster index. Regularly run analyze table or optimize table. Monitor the slow query log and fix the top offenders first. Always use covering indexes for frequent. Select plus where patterns. Avoid over-indexing. It slows down insert and update. Partition very large tables by date when appropriate. Always test performance with realistic data volumes. In conclusion, this module has taught you how to make SQL fast and efficient using indexes, execution plans, tuning techniques, and views. Tuning slow queries into lightning fast responses. You now know how to diagnose problems with explain, choose the right index types, create performance-friendly views, and apply the best practices used by professional database administrators and analysts. These skills are critical for scaling applications, meeting performance, and delivering real-time insights. In the next module, we will explore advanced SQL features such as stored procedures, traders, and database security. See you in the next module.